Hello, welcome back to the series of videos related to Fourier transforms. In this fourth video, we are dealing with a very special function known as the top hat function in mathematics. Now, the top hat function is defined as f of t is equal to 0 if t greater than a by 2 or less than minus a by 2, and its value is 1 by a if t is in between minus a by 2 and a by 2. Now, why it's top hat? The name, of course, if you observe the figure, it looks like a hat. Okay, it looks like a hat. That's why it is called top hat function. What's the specialty of this function? The very important feature of this top hat function is that the area of the area of the function of the graph, or the function of the graph, the area of the graph is 1. That is very important. You see, what's the area of that graph? So that shaded portion is actually the area that we need to find. Now if you take it as a rectangle, of course the area will be its length times its breadth. And what's the length? And you can take any one as the length, and you can take 1 by a as this length, and its breadth is equal to a by 2 minus a by 2, and you will get this is equal to 1 by a times a. So this is equal to 1. So this is the one important feature of top hat function is that it's a unit area function. Its area is unity. Now we are going to find the Fourier transform of this function. Now by definition of Fourier transform, now we can directly write f of omega is equal to 1 by root 2 pi integral minus infinity to infinity f of t into e raised to minus I omega t dt. Now we can see that our function is defined only in between a by 2 and minus a by 2. So this integral will become 1 by root 2 pi integral minus a by 2 to a by 2 1 by a times e raised to minus I omega t dt. So this is equal to 1 by root 2 pi is the constant times, and that 1 by a, it will also, we can take it outside, times 1 by a times the integral of e raised to minus I omega t. The integral of e raised to minus I omega t is e raised to minus I omega t divided by minus I omega, since we are integrating with respect to the time. So the limits is from minus a by 2 to plus a by 2. So this is equal to 1 by root 2 pi. You take the minus to the numerator and you will get I omega a, and put the limits, you will get minus e raised to minus I omega a by 2 minus e raised to plus I omega a by 2. So this problem, but it looks familiar with the previous one, that problem we have done in the third video. Okay, of course the shape of the two graphs in problem number 3 and this video is the same. So this is equal to 1 by root 2 pi I omega, and you take that minus 1 here. You take that minus 1 here into the bracket, and you can write it as e raised to I omega a by 2 minus e raised to minus I omega a by 2. Now we know sin x is defined as sin x is equal to e raised to ix minus e raised to minus ix divided by 2i. So what is, we are not having that 2i, you put a 2i. So in order not to change anything else, you multiply by a 2i on the numerator. Now what's inside that bracket is equal to sin x. So 2i times root 2 pi I omega a times sine of x. Here x is omega a divided by 2, and here you can cancel that I and rearrange everything else in a very neat way. You can put everything together as root 2 by pi sine omega a by 2 divided by omega a. And this is the final answer. You can either stop here or you can continue like this, because there is an important thing that another function is defined in mathematics as sinc function. The sinc function, you always written it as sine then suffix c, sine c of x, or sinc function. Now by definition this is equal to sine x divided by x. So if you have a sine x and if you have this x in the denominator, then we'll call it as sinc function. Or you can write, you don't need to put that as a suffix. Even you can write that c similar to other letters, sinc. Okay, sine c or sinc function. Sinc of x is sine x by x. Now you can rearrange this answer. Now you look carefully here, and we have that root 2 by pi and sine omega a by 2, that is x. The x part here is the omega a by 2, and in the denominator also that x should be there. So omega is already there. I am dividing it by a 2 and multiplying with a 2. Okay, now it's equal to root 2 by pi into 1 by 2. And the rest of is can be written as sinc omega a by 2. So that 1 by 2 and that root 2 in the numerator, we can arrange it as root 2 1 by root 2 pi of sinc omega a by 2. So in engineering, I think in engineering field this function is commonly used, but in mathematical physics we are not usually dealing with such function. We will stop here. Okay, thank you for watching. Please subscribe the channel, and we will see in another video.